This is a new project. I've got several projects going. I'm not even in camera. Anyway, I'm going to have some updates on this of a couple of other projects that I've been doing and not filming, unfortunately. Right now, I would normally use air to clean this, make sure, well, some of this grime won't come off with air, but I normally have an air hose handy when I'm milling to clear chips and whatnot. But I'll bring you a little saga of mine. About every 2 years, my home-built air compressor decides something needs to be replaced, so something on it dies. Hindsight's 2020. 5 years ago, when I first started replacing things, if I had just replaced the entire compressor for $600 or $700, I wouldn't have this issue. But after this upgrade, I will have about $700 in the rig, so it better last as long as a brand new one. Anyway, 2 years ago, a year and a half ago, I replaced the pump head. If I ever showed that or not, if I get it up here. Well, I won't mess with it. It's over there, and the pump head's over there in the scrap bin. It will eventually be melted down. Just about everything I melt down for aluminum. If it's in, I'll cut the aluminum out of it, melt it down, and I can use that for something else. But basically, it was just running fine one day. That was a 3-horse head, and I had a 3-horse motor on it, and everything's working fine until the flywheel just blew apart. I've never seen that before. I mean, it literally shattered, and then of course the motor's still running. It's just trying to drag that broken flywheel a couple revolutions until it just blew apart. So that was great. So I went and spent another couple $100 to put a new head on it. This is a 5-horse head. Now I've got a pulley on it, and I was running it a little smaller pulley, so it would run. It was geared. Basically, even though it was a 3-horse motor, it was putting about, because of the torque ratio between the two pulleys, it was pulling that just fine, or so I thought. That motor's about 10 or 15 years old. That was the first one I put on it way back when I first built this, probably 15 years ago. And that was in a previous shop, previous everything. So anyway, that thing has been moved around a lot. It's been used a lot, and that motor won't keep speed up now. I'm guessing some of the windings are weak or bad or burnt. So it gets under load, and that 5-horse compressor head, about around 100 psi, it's got too much head pressure, and it slows the motor down enough that the starter windings kick in. And of course then it spins it back up again, and so it's basically fighting. It's going between trying to run at about half speed and trying to start. So it's just back and forth, and it's just vibrating it's just really messing itself up. It has done that probably for about 30 minutes. I didn't realize what it was doing, because again, this machine is this behind the shop. If I'm in here using a loud grinder or something whine, I don't hear what the compressor's doing. Though I probably, by my own neglect, didn't hear that the motor was, surging and giving trouble until it's too far gone. So I needed a 5-horse motor. It's a 5-horse head. I thought, man, 5-horse motor is going to be $400. I've been looking. It's $400 everywhere I look. I got to give a plug. I'll put a link in the description for Surplus Center out of Lincoln, Nebraska. I've shopped them periodically, and they've always got great stuff. I found a 5-horse Leeson motor, unidirectional or bidirectional, 230 or 208 volt motor, 3450 RPM for $260. That's at least $100 cheaper than I've ever seen one. So that's what I bought, and I also went in and bought brand new everything that I hadn't already replaced. So only issue is that old motor had a 9/6. It actually had a 5/8 drive that on this mill I'm fixing to show you, I did some stupid stuff, because I'm at most I'm an amateur miller. I watch a lot of professional millers, what I call pro-am, ranging from better than me all the way up to professional machinists, millers, and lathe workers. I don't know what you call it, turning. Well, that's technically turning. Anyway, on YouTube, and that's why I've had this mill for about a year, and I didn't want to show any of my workings on it, because I'm, just go ahead and tear me up in the comments. At least I'll learn something. and I got no pride here. But I'm not going to do a lot of stuff that's wrong, and that's please just go ahead and let me know. Just be kind, please. Don't be too vulgar. Stupid me, really. That I should have known that the motor shaft's going to be a hardened shaft. I don't know. It probably was. It might have been tool steel to begin with. It certainly was hardened before it was put in the motor. And so stupid me thought I could mount that thing. My lathe is actually broken right now. I've got a little cheapy lathe. I've got a new motor for it. Also got that from Surplus Center. It's a 3-phase with the VFD. I'll bring you along once I learn how to program that silly thing. So I got to fix the lathe, but I didn't have the lathe working, and I had the mill. Okay, I'll just put an end mill on this thing, and I'll turn the motor. I'll just let the motor run, and then I will come down with an end mill and just slightly skim coat and take. It was a 5/8. I was going to try to take it down to a 1/2 inch, the motor shaft, the old motor shaft, because I've got a 1/2 inch double V pulley. I got it down to a 9/16. I went through every end mill I had because, again, I'm turning with a high-speed steel end mill. I'm trying to cut something that is several classes harder than the stupid cutters. So even taking light coats or light cuts, it was just destroying my bits. So what I'm going to do today, though, the new motor's got a 5/8. I managed to get that shaft to a 9/16, and then I bored. I've got a 9/16 bit. I just bored that pulley up to a 9/16. Worked fine. Put them together. It's worked for a year and a half now. This was a year and a half when I did that. It's when I replaced the other head. So today I've got a 5/8 shaft on the motor. Again, it's a 5-horse. It's an upgrade of that one, a better brand, and it's also a lot stronger. It's a 5-horse, like I say. So the pulley I've got is 9/16. I've got to bore it to 5/8. I've got a 5/8 bit, so I'm going to chuck it up in a lathe. Sorry, not lathe, mill, and bore it 5/8. It's going to be a little over because I'm just drilling it. I don't actually have a boring bar or a reamer to get it perfectly 5/8, but it's keyed anyway. So I'm going to go 5/8. It'll be close enough. I'll tighten it up with a key. It's belt drive. There's not going to be a whole lot of shake in it, but anyway. If I had a set of reamers, I would ream it, but doesn't have to be that close of a fit. I mean, if I'm plus or minus, well, hopefully over 5 thou, then it'll slide on and I shouldn't have a problem. So I'm going to point you at the mill, and then I'm going to start chucking up that pulley, and we'll get the wire. Make sure it's on. I've got a kill switch on it for when I'm putting. Have that in shot. I'll swing around there. So I've got a double safe kill switch. I would recommend you unplug your mill, but instead of unplugging it, which is a pain in the rear end, I've just got an extension cord on it, and I've just got a kill switch. So, and I've got that's off when it's down. I've got a power light over here on the controls. If you can see that, you can see my messy shop in the rear end. So that power light comes on when it's on. I'll make sure it's not on when I'm changing bits. It'd be pretty hard. I mean, you have to really think about hitting the forward or reverse, but I don't want to take any chances. That thing's got some power to it. This is a Grizzly. Let's see, it's a Golf 0705. G0705 mill. It's a mill drill, or drill mill, meaning the turret moves, or I move the head down. I move the head or like a mill, versus a knee mill, where this would all be stationary, and the platform would move up into the cutter instead of the cutter moving down. That's the difference between the two styles of mills. I don't have room. I'd like to have a big Bridgeport or something like that, but this is about the size for my shop. Gotta find. Where is it? Well, of course, I never can find the tools I'm looking for. I think that's the right size. Here it is. It's got a collet in right now. I've got to remove I'm going to need to get Well, I got an aluminum block here. It works pretty good for a whammer. Soft enough it won't mess up that drawbar. So yeah, I just tore that one all to crap. I think that was the same. That may not. That may have actually been a different project. Yeah, it's definitely destroyed. Anyway, let me put that collet away. I try to keep my collets in the actual plastic containers that they came in when I can. Get the moisture off of them. I periodically spray them down with WD-40. Need to get some bow shield, but anyway. Okay, let's get this. Where's the slot? There's the slot. Get him pulled in tight. Yeah, I'm definitely going to have to go up with this head. This has got an adjustable head, and it's really pretty. This was actually a very tight machine. I was surprised. Beardsley makes good stuff. I got this for. I got a steal basically. This is a one owner. I believe the previous owner bought it at the scratch and dent sale that they have in the summer. I don't know. I mean, I did rebuild a little bit of the box, the control box, but really there's really not much wrong with it. So, but I got a great deal on it, so I was kind of surprised at how well it performs, being as cheap as it is. Okay, but I'm gonna have to raise this all the way up because I do not have any stubby stubby drills. High speed steel. Double check that. So there on the bottom, 15.2 mil. Well, that's a .060. That's strange. I know it's a 5/8 mil. I mean, it's 5/8 high speed steel. Well, but it's registering. I don't know if you can see that. If it's that coming in clear. It's .060 or .60, sorry, which actually is good because with a little bit of run out, it'll be a .625. So it's gonna be a better fit than I expected. And that's gonna be too far down in there. Get some parallel. And probably use a decent set of parallels here. That's the problem I'm going to have though. With this vise, that parallel can't sit all the way against the fixed jaw because the parallel drops off the milled edge. Now this rig, I do not have a DRO. This is all standard. But obviously for finding that, it's already it's already a decent hole. It's 9/16. Close enough to size that I can spot it with. I wish that wasn't on there. And by eye. I do believe that's centered enough for me. Okay, so let's drop the head down. There we go. This shaft actually, I believe the The keyway, or the very first of it, was actually drilled 5/8. Because this bit actually starts down in there, and then the rest of it is only 9/16, so which is fine. Okay, so now we're going to turn it, take it off of double safe, whatever. Oh, let's see, forward. There's forward. I got a good cut, it's just squeaking a lot. That's fine. Put a little tap magic on it. One thing I thought about while I was running that down is I didn't actually check I should have trimmed the top of this head to make sure that's actually square with the table and the rest of the mill. I'm pretty sure it is. I've trimmed this table, and I trimmed this vise when I mounted it last, and it was within a thou. I think it was maybe 2 thou, maybe a negative thou here and a positive thou here. So the center's pretty close, and I'm trusting those parallels. I'm about afraid to pull that down there and trim that now, because it may make a liar out of myself. Okay, that's a pretty. I think we can make that work. I might shave a little bit off of that key. I can't for the life of me remember what I was going to say. So, oh well, must not have been very important. I got to say that fits pretty darn snug. It's not exactly. Anyway. Yeah, it's not perfectly